Problem 16. A square and a circle have the same area. Let's assume the side length of the square is L and the radius of the circle is R. Because their areas equal, so we will have L squared equals pi R squared. And then we can get L over R squared equals pi. That means L over R equals square root of pi. The answer is B. Let's assume these points are A, B, C. Because PQ bisects the area of the octagon, and the octagon consists 10 unit squares. Therefore, we know that the area of PAQ plus the square YABC equals 5. And the triangle PAQ equals 1/2 PA multiply AQ plus YABC is a unit square, so its area is 1. That equals 5. Then we get PA multiply AQ equals 8, because PA equals 5, so AQ equals 8 over PA equals 8 over 5. So QY equals AQ subtract AY, which is 8 over 5 subtract 1, that equals 3 over 5. Then XQ equals 1 subtract QY, and that's 2 over 5. Therefore, XQ divide QY equals 2 over 3. So the answer is D. Problem 18. Because the question asks the ratio of the area of the rectangle to the area of the combined semicircles, and since it's a ratio of the areas, so the unit or their absolute value of AB and AD do not matter. Therefore, to simplify this problem, we simply assume the length of AB is 2 and the length of AD is 3, because their ratio is 2 to 3. In this case, the area of the rectangle equals AD multiply AB equals 3 multiply 2 equals 6. And two semicircles combine into one circle, so the area of the circle equals pi R squared, and R, the radius of the semicircle, equals AB over 2. And that equals pi. Therefore, the ratio of their area is 6 to pi. The answer is C. Problem 19. The larger circle has radius AC and the smaller circle has radius BC. So to calculate the difference in their areas, we use pi AC square subtract pi BC square to get their area difference, and that is pi AC square subtract BC square. Because triangle ABC is a right triangle at angle B, therefore AC square subtract BC square equals AB square. So this can be simplified as pi AB square, because B is the midpoint of AD. So this can be further calculated as pi AD over 2 square. And AD has length 16, so that equals pi multiply 8 square equals 64 pi. So the answer is C. Problem 20. To minimize the number of people in the room wearing both a hat and a glove, we want the people that are not wearing gloves or wear hats. So in this case, we use the 3/4 ratio of people that are wearing hats subtract the ratio of people that are not wearing gloves. That's 1 subtract 2/5. So we simplify that. That's 3/4 subtract 3/5. And that equals 3/20. Because the number of people in the room will be an integer. So for this ratio 3/20 to multiply the number of people in the room to make the result an integer, the number of people has to be at least 20. So the minimum number of people in the room wearing both a hat and a glove will be 3/20 multiply 20 equals 3. The answer is A.